So in this video, I'm going to show you how to solve an equation that has logs on both sides. Now, in the examples that I've showed you previously, what we've done is we've only had logs on one side and a number on the other side, and we've condensed all the logs together into one expression, and then we change it to exponential form. And that's perfectly fine to do in this example. If I want to keep using that method, I would subtract log x from both sides. I would subtract log 15 from both sides, and I would have it equal to 0 on the right-hand side. And then I would go through the process of combining three logs, put it in exponential form, and then solve for x. However, there is a shorter method. When you have logs on both sides, what you can do is just condense any logs that you have on each side separately, and then set the expression that you're taking the log of on each side and set them equal to each other. So what we're going to do, since this side of the equation is already condensed, I'm going to leave it alone. But on the right-hand side, we have two log expressions separated by an addition sign. So that means I need to combine this into one log expression using multiplication. So this is going to be log of 15x. Now, because log is a one-to-one function, whatever is inside here has to be equivalent to this. So, for example, to understand the concept of what I'm trying to tell you, if I gave you, let's say, log of 7 is equal to log of x, just to break it down into something a little bit easier to comprehend. If those two expressions are equivalent to each other, x has to be 7, because whatever this is has to be equivalent to this. So what we're going to do is we're just going to set what's inside here equal to what's inside here if I want the whole entire equation to be equivalent. If I want the left-hand side to be equal to the right-hand side, then what we're taking the log of has to be equivalent, because log is a one-to-one function. So I'm going to have x plus 15 is equal to 15x. And then I can just solve this equation here. So I'm going to subtract x from both sides. And then I can divide by 14. And my answer will be 15 over 14. And then if I want to give it a decimal approximation, this would be the exact value. But the decimal approximation would be x is approximately 1.07149. Actually, I think that's 142, and I read that on my calculator incorrectly. Let me fix that.